The time has come to talk about one of the core behaviors in Git, which is merging changes between branches. As critical as this operation is, you would think that the help text might be, in fact, helpful. And it kind of is, but only because of the pretty pictures. What these two diagrams are conveying to you is that if we have two branches, master, main, being our primary, and then a branch called topic, and both are continuing to have commits as they go, a merge then will be a final commit H here that brings the changes that were last introduced in C and all through ABC into the main branch through these other commits. That might seem like a bunch of word salad. Again, it's something that makes much more sense in practice. So let's just do it. We're going to start by switching over to our main branch and add a few more commits to make this clear. So we'll add some detail to file1.txt, some continued main updates, add some stuff to file2.txt, and do the same thing again with commit. All right, we've got some extra commits on main. But now let's merge experiment into our main branch with git merge experiment. So that's the basics of this syntax. We're on a branch, we use git merge, and we name the branch we're merging into where we currently are. Now this is a commit that we're making, this merge. And so I can just let this go. It will open up Vim, or I can use -m to provide a commit message on the command line. We get some information back. First of all, we're told that the merge was made by the ORT strategy, which is the default. You can look up git merge strategies on the Git documentation, and the text has a link to that page. And of course, you can see that now in our main branch, we have an experiment.txt. Now that we have a couple of different timelines that sometimes interact, sometimes don't, it would be cool if we could visualize that, and in fact, we can. We've already seen git log with one line, but let's now see it with -- graph. We get this nice little ASCII art diagram of the branches here. And in a graph version of the log, the leftmost line is always the branch that we're currently on. And so you can see that from our perspective here on main, there was an experiment branch that was made. We had these other commits here. This is where experiment is currently. And then it was merged back in to main with our most recent commit. Now, one question we might want to ask ourselves is when we have a separate branch for a different feature or a lot of extra bug fixes, and there's hundreds and hundreds of commits inside that branch, do we need all of that commit history represented in our main branch? The answer may be no, and for that reason, we have another tool called squashing. Let's create a new branch here to demonstrate what this is all about. So we're going to use git switch this time. I've kind of gotten over checkout. We're going to use git switch here, -c for phase 2. All right, phase 2. We're going to make a new file with touch phase2.txt. We're going to git add phase 2. It's an empty file, but whatever, phase2.txt. Then we're going to commit that add phase 2, even though there was nothing in there. And the next thing, we're basically going to make 10 different commits just to make some noise here. And I have a one-liner in the text, which I strongly recommend you use for brevity's sake. We'll go through it quickly just to see what it's doing. We're using bash, so even if you're using fish, this will work just fine. And we're going to basically say for I in seek 10, this just creates 10 integers, 1 through 10. And what do we do for each one? We're going to echo step 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 into phase 2 on a new line. And then we make the commit with AM and then step I and then done. So we're basically automating the add and commit parts of this for these extra components of phase2.txt. See that? We can see it here if we do git log one line. Look at all of these. Now, do we need all of these in main when we merge phase 2 into main? If we don't, then we have another option. Let's git switch back to main. And we're going to use git merge -- squash phase 2. A squash commit is a little bit interesting because it does bring all of those changes into a single commit, but it doesn't make it happen. It adds the changes. If we look at git status here, you'll see that we have a new file phase 2, but it didn't actually make a commit. That's why we have the gold indicator here. It allows us to add the commit message. And you cannot, for this one, pass a -m. We have to separately use git commit -m, and we'll do merge phase 2. Let's take a look at the git log for this. Look at that. It didn't even show us the separate branch. It just showed that we had a merge of phase 2. The whole history of what happened with phase 2, it still exists on the phase 2 branch, but we didn't feel it was necessary to bring all of that noise into the main branch, and so we squashed it into a single commit that we see here. Now that's all we really wanted to do with the phase 2 branch, so we're going to blow it away with git branch -D phase 2. That's what happens when merges go well. But in the next lesson, we're going to talk a little bit about what happens when merges go wrong and how to handle merge conflict resolution.